All right, so next we're going to look at logarithmic functions. Now, the first writings to the left says x is equal to log to the base a. So that's how you read it. X is equal to log to the base a of y. Now, in that statement or in that equation, x is the index, a is the base, and y is the number. So basically what we're saying, the log of a number to a base is equal to another number. So the log to the base a, so the statement reads, x is equal to the log to the base a of y. So we're finding the logarithms to the base a of y, and that is equal to x. Now, the statement on the left could be written. So the form it's in on the left is called the logarithmic form or logarithmic form. Now, the same statement is written on the right, but the form that is written on the right is called the index form. So in other words, it is saying that the number is equal to the base raised to the index. So you can move now between log form and index form. In the log form, you said that the index is equal to log to the base a of the number. In the index form, it is saying the number is equal to the base raised to the index. So what is a logarithm? A logarithm of a number is defined as the power to which the base has to be raised to be equal to the number. The logarithm of a number. So if we are saying the log to the base a of y, the logarithm of the number is the power the number has to be raised, the base has to be raised to be equal to the number. So very important definition, because moving between the log form and the index form depends on your knowledge of the definition. So the definition is saying that the logarithm of a number to a particular base is the power. So the logarithm is the power to which the base has to be raised to be equal to the number. So if the logarithm to the base logarithm to the base a of y is equal to x, it means that the number y is equal to the base a raised to the power x. All right. So it's the definition that allows us to move between the logarithm form and the index form. So here, this statement says we can convert an exponent to a logarithm and a logarithm to an exponent using the definition. So example 31, I'll start and then you can finish the example. In example 31a, it says that x is equal to 1.5 to the power 6. That is index form. Moving to logarithm form, it would be the logarithm of the number x to the base 1.5. So 1.5 is the base, is equal to the index, which is 6. So in moving from the index form to, in the index form, it is the number is equal to the base raised to the power. In the log form, it is the log of the number to the base is equal to the power. Again, in the index form, it is the number is equal to the base raised to the power. In the log form, it is the what? Logarithm of the number to the base is equal to the power. All right, please attempt the rest of example 31. All right, so B, y, at B, y, the number is equal to 2 the base raised to the power of 4. Now in log form, it's going to be the logarithm of the number y to the base 2 is equal to the power, which is 4. At C, it is the number 8 is equal to the base 3, sorry, the base A raised to the power of 3. In log form, it's going to be the log of the number 8 to the base A is equal to the power 3. Try these 5.6a. It is the number x is equal to the base A raised to the power 2. In log form, it's going to say the logarithm of the number x, the logarithm of x to the base A is equal to the power 2. B, it is the logarithm of the number 16 to the base 4 is equal to the power 2. And for C, it is the logarithm of the number 10 to the base A is equal to the power, which is x. So one of the first thing we need to learn when we're doing logarithms is how to go between the index form and the log form. And of course, it is the definition for logarithm that allows us to do that. Now, the definition of the logarithm of a number is the number to which the base must be raised, the power to which the base must be raised in order to be equal to the number. All right? Turning the page. Now, example 32. For example 32, we have to do the reverse. We have to now go from log form to index form. Now, in moving from log form to index form, it is the number 6 that is equal to the base A raised to the power 3. Please attempt the rest. Right, so at B, it is the number 4 is equal to the base 2 raised to the power x. At C, it is the number 7 is equal to the base 4 raised to the power y. Try these 5.7a. It's the number y is equal to the base 3 raised to the power 6. At B, it's the number 10 is equal to the base 3 raised to the power x. And at C, it's the number 6 is equal to the base x raised to the power 4. So again, for this topic, one of the first things you need to be able to do is to convert between the logarithm form and the index or the exponential form.